Good
Good
morning,
morning.
sir.
Good morning, sir.
Good morning, sir.
Morning.
Good morning, sir.
Okay, so let us start. Okay. So now, the last class we discussed the types of differential equation, the classification of differential equation, like linear, nonlinear differential equation, or homogeneous, non-homogeneous differential equation, and another one is constant coefficient and variable coefficient differential equation. So these are the classification of the differential equation. Well, uh, next, that is the solution. What is the solution of a differential equation? Okay, and the solution of differential equation. Okay, so in generally, the solution is what? We satisfy the differential equation. Is that not? The solution is a function which satisfy the differential equation. What is? Suppose I am saying, suppose the differential equation, you can say this, we take a second, okay, general order first order differential equation. Suppose you see the general for a linear differential equation. Okay, suppose I am writing this is yn plus a1 yn minus 1, okay, plus a2 yn minus 2th derivative. Similarly, this is a1 y dash, okay, plus an y is equal to f of x. So this is the general form of a linear constant coefficient differential equation. If f of x is equal to 0, then it is homogeneous, otherwise non-homogeneous. Okay, then this is general form of linear constant coefficient differential. And if your a1, a2, an, sorry, this is n minus 1. Okay, and suppose this a1, a2, an minus 1, an, or these are constant, then this is constant coefficient, and if these are variable, the function of x, then it is variable coefficient. Okay. Okay, suppose this is the general form of a differential equation. So we say, suppose the solution, okay, uh, another one is, acha, another thing is, okay, you just remember another one. This is the general form of a differential equation. And another form is there. I can say this is f of, okay, this is f of, I can say this is small f. Oh, sorry. This is x, y dash up to y is equal to 0. So here you see this is also a general form of a differential equation. Nth order. Okay, this is also a nth order differential equation. This is another form. Understood my point? And here you see in these two form, okay, two types of differential equation. So the first one is what? The first one is the explicit form. Explicit form means the differential equation that is we write this is nth derivative, then some constant or some coefficient into n minus 1th derivative, again some coefficient into n minus 2th derivative, then up to y is equal to f of x. And this differential equation you can see how many terms are there, okay, and which terms are there. Okay, in the differential equation you can see f of x means this is a function of x, so here x is one variable, then y is another variable, y dash is another variable. Similarly, y nth derivative is nth derivative of y is also one variable. So we can say here this is a function f of x y dash y nth derivative is equal to 0. This is also another form, a general form of a differential equation. Okay, because in partial differential equation and in ordinary differential equation also, okay, you can find this type of form. Okay, so,
Yes.
but when we say the solution, about the solution, let us okay, let this y is equal to hx be the solution, be the solution of differential equation y. So this, okay, let hx be the solution of a differential equation. So when we say the hx be the solution, if hx is satisfied, okay, if hx satisfy the equation 1, okay, then we can say yes or no. So this is a different solution of a differential equation. That means we can say the solution of a differential equation. Okay, so if you write the definition, okay, of the solution, okay, you can say the solution of a differential equation, solution of a differential equation is any function, is any function, is any function which satisfy, which satisfy the equation, satisfy the differential equation. Okay, satisfy the differential equation. That is, it reduces to its identity. Okay, that is, it reduces to identity. Reduces to identity means when, if suppose, uh, for example, we say y double dash uh, uh, plus y is equal to 0. Suppose this is differential, and I am saying that the solution is y is equal to suppose I am writing cos x. Cos x is the solution. So how we say this y x is equal to cos x is a solution or not? So I substitute in the equation. If the both sides same, then we can say cos x is the solution. That means if y is equal to cos x, then if I find y dash is equal to how much? Minus sin x. Okay, and y double dash is equal to again minus cos x. Okay, now if you substitute y double dash plus y double dash plus y, and which is equal to, this is what? Minus cos x plus cos x is equal to 0. So this satisfies this equation. And if the solution satisfy this differential equation, then you can say this cos x is the solution. Understood or not? The definition says something, same thing. The solution of a differential equation is any function. We satisfy the differential equation. We satisfy the differential equation. Okay, but the solutions are different types. Okay, solutions are different types. So let us see. First we say, first we say explicit solution and implicit solution. Explicit solution. Okay, and another one is implicit solution. Implicit solution. So what is explicit and implicit solution? And in general, you should know what is explicit function and what is implicit function. Okay, explicit function and implicit function. Okay, suppose we can say, okay, come to here. Okay, come back. I'll come back. Suppose we say, suppose y is function of x. Y is a function of x. So here x is independent variable. Independent variable. And y is dependent variable. Yes or no? Here x is independent, y is dependent variable. Now when you write the function yx, if yx is equal to only function of x, function of x means, suppose I am writing this is x plus e to the power x. Okay, yx is equal to x plus e to the power x. So this is what y can be expressed. Okay, the dependent variable, y is the dependent variable. This dependent variable expressed using by terms of only independent variable. Then you can say this is explicit form. And what is implicit form? Implicit form like this. Suppose I can write this is I can say this is f of x comma y. This is equal to 0. This is the implicit form. Because here the function, here x is independent variable, y is dependent variable. Okay, but it is written like this. Now, for example, I can say in this way, suppose x into y plus x square into y dash. Okay, like this. Suppose x into y square, x square into y, sorry, x square into y is equal to 0. Is equal to 0. Okay, so this is the implicit form. This is the implicit form. Okay, because x and y they can any form. Okay, in the function. Understood my point? Or what is explicit and implicit form? The same thing here I can say.
Sir, can you repeat? Okay.
Okay, explicit form means what? Suppose your y is a dependent variable, x is independent variable. So when you write the dependent variable in terms of only independent variable, that means yx is function of x only. That is, you can write y is equal to x plus e to the power x. Your right hand side always function of x only. Understood my point? Because y can be written as in the terms of x, then we can say this is explicit form. Okay, then we can say this is explicit form. And if what is implicit form? Implicit form is your x and y they together written. Okay, like x y square plus x square y is equal to 0. Uh, Understood my point? Here what? Your independent variable and
Yes,
dependent
sir.
variable, they written simultaneously. Okay, and this type of function or this type of form is called implicit form. Okay, the same way we define the solution. Okay, what is the explicit solution? What is the implicit solution? Okay, and the explicit solution you can say the dependent variable. You can say same thing. You have to write in explicit solution. Okay, I'm writing here. Explicit solution you can write the dependent variable can be expressed. The dependent variable, the dependent variable can be expressed in terms of the independent variable. Okay, in terms of independent variable. Okay, the dependent variable can be expressed in terms of an independent variable. Okay, that is the explicit solution. That is y is equal to f of x. Suppose your differential equation is whatever you write, for example, you can say y is equal to f of x. Oh, f of x, this is only function of x, and y is the dependent variable. So here you can say y is equal to f. This is the explicit form. Okay, and in implicit form is what? The implicit solution is like this. When you write, suppose this f of x comma y is equal to 0. Suppose y is the solution. Okay, sorry, a is लिखो hx. Okay, you write here hx. Okay, and implicit solution क्या होगा? If the solution in the form of, okay, the solution in the form of, okay, in the form of like this, f of x y is equal to 0. Here y is dependent variable, x is independent variable. Okay, f of x comma y is equal to 0. And in that case, we can say this is implicit solution. Okay, and in generally what happen when you solve the partial differential equation, okay, in that case you can find the implicit solution. Okay.
Sir,
Hmm.
will the definitions come in exam?
No, no, no. Definition will not come.
Thank you, sir.
Okay. Okay. So you just wait 1 minute. I just put my 1 minute. Okay. You just uh, read it. Okay, let us start. Okay, so this is explicit solution and implicit solution. Okay, so let us see the types of solution. So in generally what happens? When you solve a differential equation, okay, you will get a general solution. Okay, a general solution. Okay, a general solution. So what is general solution? So general solution means it is complete solution. Okay, complete solution. General solution means this is complete solution. Okay, and what is general solution? General solution means the solution of a differential equation. Okay, the solution contains the arbitrary constants. The solution contains arbitrary constants. Okay, and you know that suppose you solve a differential equation, for example, okay, first you write the definition. The general solution, the general solution of a nth order, okay, nth order differential equation, okay, the general solution of a nth order differential equation uh, uh, contains n arbitrary constant, n arbitrary constant, okay, n arbitrary constant. Okay, the general solution of the nth order differential equation contains n arbitrary constants. That means the solution containing the arbitrary constant is called general solution. Okay, for example, let us see. Suppose uh, we solve y dash is equal to, we say this is x square. So y dash is equal to x square into y. Suppose y dash is equal to x square into y. So now here you see, when you solve, you know how to solve this first order differential equation. Suppose this is dy by dx is equal to x square into y. Okay, so now you separate the variables that dy by y is equal to x square dx. Okay, y on one side, x on one side. So now you taking integration both sides. So you will get this is ln y is equal to this is x cube by 3 plus c. Yes or no? Because in indefinite integration, okay, a constant will be there. And c is the arbitrary constant. So now here you can say this y is equal to this is e to the power x cube by 3 plus c. And again you can write this is e to the power x cube by 3 into e to the power c, and which is equal to this is some constant k, okay, into e to the power x cube by 3, okay, e to the power x cube by 3, and this k is nothing but e to the power c, another constant. Okay, so this is the solution, and you see this solution contains an arbitrary constant. Okay, so this is the general solution. Okay, the general solution contains arbitrary constant, but here you see this is a first order differential equation. Only y dash is equal to x square y dash. So if first order होगा तो how many constant? Only one constant, k is there. And if you solve a second order differential equation, suppose for another example you solve y double dash is equal to suppose x. This is second order differential equation, and if you solve it, so how do you solve? So you can say this is dy dash by dx is equal to x. Is it correct? Because y double dash is derivative of y dash. So here you can say this dy dash is equal to x dx. Now you taking integration both sides. So what you get? You will get y dash is equal to this is x square by 2 plus c. Again, this y dash is nothing but dy by dx. the dy by dx is equal to x square by 2 plus c. So if you again separate the variable, dy is equal to x square by 2 plus c dx. Now taking integration both sides. So what you get? You will get y is equal to, this is x square by 2 integration, that is x cube by 6 plus c का integration क्या हुआ? C is a constant, so dx का integration x plus another constant d. Okay, so here you see the solution contains two constants c and d. Why? Because this is a second order differential equation. So that means the general solution, if you solve a nth order differential equation, okay, the general solution contains in n arbitrary constant, n arbitrary constant. Understood?
Sir, you can scroll the screen up. Let me copy, sir.
Yeah. Okay, so the general solution of a nth order differential equation contains n arbitrary constants. Contain n arbitrary constants. So similarly, you can solve third order, fourth order, but you know only to solve the first order differential equation. Okay, and second order, third order differential equation, you have to know. Okay, okay. So now you see the general solution is what? The general solution of a nth order differential equation contains n arbitrary constants. So now here C and D are what? Arbitrary constant. And if you put some value to C and D, then you will get a solution. And that solution is called particular solution. Okay. And another solution is, that is particular solution. Particular. Okay. Particular solution. Okay, the particular solution क्या है? The particular solution is a solution obtained from the general solution by choosing a particular value of a arbitrary constants. Okay, so you can say particular solution, the particular solution is a solution obtained from the general solution. Obtained from general solution by choosing the particular value of particular values of arbitrary constants. Okay, arbitrary constants. Understood my point? What is particular solution? So general solution से तो constant है, arbitrary constant. वो arbitrary constant को particular value put कर दोगे, तो you will get a particular solution. You will get a particular solution. Okay, so how to find particular solution? Okay, the particular solution, suppose for example, let us see, suppose you have one question, y dash is equal to, suppose this is y dash is equal to y. Okay, so y dash is equal to y. If you solve this, so what you get? This is dy by y is equal to dx. If you take integration both sides, then ln y is equal to, this is x plus c. And if you write in terms of y, then this is some k into e to the power x. Okay, so this is the solution. Y is equal to k into e to the power x. This is the solution. So here a k is arbitrary constant. K is arbitrary constant. Yes or no? Here k is arbitrary constant. So how to find the k? For which value you have to put at the place of a k? Okay, so you have to put some particular value, and that particular value how to put? You don't put arbitrary. Okay, तो k का value put करने के लिए some conditions are given. Some conditions are given, and that condition is called initial condition. Okay, so when you solve a differential equation, and you have to find the particular solution, then some initial condition must be given. But you have to choose some initial condition. Initial condition means y0. Suppose y0 is equal to 1. This is your initial condition. y0 is equal to, this is your initial condition. ओके तो ये इनिशियल कंडीशन पुट करोगे तो k का एक पर्टिकुलर वैल्यू मिलेगा, k का एक पर्टिकुलर वैल्यू मिलेगा. तो लेट अस सी हाउ टू पुट. सपोज y0 is equal to 1 means what? At x is equal to 0, at x is equal to 0, your y is equal to 1. So that means you can put, suppose you put y0 is equal to 1. So this implies this 1, y is equal to 1 and your x is equal to 0. So what you get? Your k is equal to 1. So k is equal to 1 is the particular value. Okay, that means your particular solution, you will get your y is equal to only e to the power x. Y is equal to only e to the power x because your k value is equal to 1. Okay, and that particular value you can choose from the initial condition. Okay, understood? And let us see another solution. I just tell you another solution is singular solution. Another solution is singular solution. What is singular solution? The singular solution is a solution, you can say it is a solution, okay, of the differential equation, the solution of a differential equation which does not satisfy the general solution. Okay, understood? So it is a solution of the differential equation which does not satisfy the general solution. That means singular solution क्या होगा? General solution एक होगा जिसमें arbitrary constant होगा. Yes or no? Normally क्या होता है? The particular solution coming from the general solution. Okay, but different solution coming from the general solution. Okay, different solution coming from the general. But singular solution is the solution which satisfy the differential equation, but not coming from the general solution. Not coming from the general solution. Okay, that is singular solution. And this type of solution, you can see this type of singular solution in generally obtained from the nonlinear equation. Okay, the nonlinear equation में क्या होता है? This type of solution generally occur. Okay, suppose you can see one example of a singular solution. देखो, suppose y dash square, okay, y dash square minus xy dash plus y is equal to 0. This is a nonlinear equation because y dash square is there. Y dash square minus xy dash plus y is equal to 0 is a differential equation. So here you can say if you find the solution, देखो nonlinear equation का solution find करना बहुत difficult है. Okay, but यहाँ पे क्या होगा? यहाँ पे y dash square minus xy dash plus y is equal to 0. So this is nonlinear equation. So there is no usual method to find the solution. Okay, and you can say suppose a general solution is given in the book. You can see the general solution I am writing. This is y is equal to suppose cx minus c square, cx minus c square, and c is the arbitrary constant. C is the arbitrary constant. This is the general solution. But singular solution एक होता है. The singular solution is what? This y is equal to x square by 4. X square by 4. So here you see this x square by 4 does not coming from the y, not general solution. Okay, these two solutions are totally different. Okay, so in singular solution normally occurs happen in the nonlinear case. Okay, because in nonlinear case, the solutions are what infinite form. Okay, differential equation का solution क्या होता है? If you find a general solution, this is also infinite solution. Yes or no? Because the arbitrary constant is there. Arbitrary constant का value change करोगे तो particular solution different particular solution आएगा. Okay, but नॉनलिनियर इक्वेशन में क्या होता है? नॉनलिनियर इक्वेशन में तुम्हारा जो सॉल्यूशन होता है, दिस इज नॉट यूनिक सॉल्यूशन. ओके, द यूनिक सॉल्यूशन मींस नॉट यूनिक फॉर्म. डिफरेंट फॉर्म में सॉल्यूशन आएगा. डिफरेंट फॉर्म में सॉल्यूशन आएगा. So that is why one solution, in that case, a singular solution occurs. Okay. You just remember a singular solution because you are not solving the nonlinear equation. You only solve the linear equation. Okay. Because there is no particular method for solving nonlinear equations. Okay. Okay. So let us see. Okay. So what is initial value problem? Initial value problem. In shortly, we can say this is IVP, initial value problem. Okay, तो initial value problem क्या है? IVP, initial value problem. So initial value problem means the initial condition is given. Initial conditions are given. Initial conditions are given. Okay, so that means what? The differential equation along with some initial condition. Okay, the initial value problem means a differential equation. Initial value problem is with the differential equation. Differential equation. Differential equation subject to the condition on unknown function and its derivatives preceded one or more values. Okay, that means you can say in a simply way the differential equation uh, along with, okay, the differential equation along with the condition along with the conditions on unknown function. Okay, on unknown function and its derivative. And its derivatives. Okay, understood my point? The differential equation along with some conditions on unknown function and its derivative. Okay, that is the initial value problem. So in general, this is the definition. So in particular, you can say when you know some initial condition by initial value problem. So the differential equation along with the solution at uh, along with the solution at initial points. Initial points of the domain. Okay, the differential equation along with the solution at initial points of the domain. Okay, so domain means what? Suppose, okay, for example, suppose I am saying this y dash is equal to y, y dash is equal to y, y dash is equal to y. So y dash is equal to y. This is a differential equation. Okay, but initial condition you may everybody know y0 is equal to any constant. Suppose I am saying 1. Yes or no? That means y is the solution. The solution and initial point is given. The solution at initial point is given. And in generally what happens? we just put x is equal to 0, y0 is equal to something. This is the initial condition. So why you always take 0? That does not mean that. The general form says that this is y of at x0. X0 is the initial point, is equal to y0. This is the general form of the initial condition. Y of x0 is equal to y0. And this x0 is the initial point of the domain. Okay, initial point of the domain. And y0 is what? The solution at x0. Okay, because y is the solution. Understood my point? This x0 is the initial point of the domain. Okay, so generally what happens? So when you solve a differential equation, okay, when you solve a differential equation, so generally what happens? We take the domain, okay, that is 0 to infinite. 0 to infinite. This domain we take, okay, 0 to infinite. So that is why your initial point क्या होगा? Initial point 0 होगा. This is the initial point. Understood or not? Now, if you take the domain that is 1 to infinite, then this is your initial point. Okay, this is your initial point. Okay, but it depends on the domain. It depends on the domain. तुम्हारा domain जो होगा, whatever be the domain का जो starting point होगा, that is your initial point. That is your initial point. And the solution and initial point is given. That is the initial value problem. Initial value problem. Okay. And similarly, if it is a first order differential equation, okay, if it is a first order differential equation, then only one initial condition is necessary. And if you can say the second order, okay, second order initial value problem, okay, second order initial value problem. In second order initial value problem, so this is a second order differential equation. Y dash plus a into y dash plus b into y is equal to 0. I am just writing a simple differential equation. Okay, this is second order differential equation with the initial conditions. Initial condition क्या होगा? यहाँ पे दो initial condition चाहिए. यहाँ पे दो initial condition चाहिए. Understood my point? Whatever be the order of differential equation, then that number of initial conditions is same as the order of a differential equation. If it is a second order differential equation, then two initial conditions must be given. Two initial conditions must be given. Understood? Suppose here y double dash plus a y dash plus by is equal to 0, where a, b are constant or a function of x, whatever. Suppose this is the this is a differential equation. So two initial condition given, and that two initial condition क्या है? In at initial point it is given. One is y at x0 it is given, that is y0, and another initial condition is y dash x0. That means the derivative of y at x0 is equal to given. That is y0. Another notation y0 and y0. So these two initial conditions must be given. Okay, these two initial conditions must be given. So here you write, okay, don't write y0. You write this is y of x is equal to p. Suppose this is okay, p and q is any constant. Understood my point? So when you consider a initial value problem, okay, so if the differential equation of nth order, then n initial conditions must be given. Okay, and similarly, if you consider nth order differential equation, okay, nth order initial value problem. Initial value problem means differential equation. Okay, this nth order initial value problem. So here you see, suppose this is nth derivative plus a1 into n minus 1th derivative. Then similarly, it is a n minus 1 into y dash plus a n y is equal to f of x. Whatever the homogeneous, whatever you can take. Okay, suppose this is the nth order differential equation. And what is the initial condition? तो initial condition क्या रहेगा? y0 रहेगा. y0 is equal to, suppose you can say t1, y dash 0 रहेगा. हाँ, okay. Suppose 0 is the initial condition. Okay, you can you write general form. You write, suppose y of x0. Suppose this is your p0. Y dash x0. This is your, suppose, p1. And similarly, similarly, y n minus 1th derivative of x0 is equal to en minus 1. Okay, this is the initial condition. So, n initial condition, y say n minus 1th derivative of y. Okay, if it is nth order differential equation, then initial condition up to what? Y of x0, y dash x0, y double dash x0, then up to y n minus 1th derivative x0. That is तुम्हारा order n होगा तो n minus 1th order, तो just one previous, okay, order तक initial condition जाएगा. Understood my point?
Yes, sir.
Okay. So this is the initial value problem, and in initial value problem, the solution of initial value problem is a particular solution. Okay. Okay. So this is the about the solution, and geometrically, the general solution of a differential equation is a family of a chord. Okay, is a family of a chord. Okay, general solution of a differential equation is a family of a chord. For example, suppose this is the x-axis and this is the y-axis. Okay, if you find the general solution, suppose I can say this is your solution. Suppose this is your 0 and this is up to infinite. Means 0 से start किया because I take the domain 0 to infinite. Okay, then suppose this solution is like this. Okay, suppose your solution is like this. Okay, then you can say, oh sorry. Okay, suppose this is your solution. Suppose this is your solution. Okay, and this is a family of a chord. Family of a chord. Like this. Okay, this is a family of a chord. Understood? If you find the general solution or draw the general solution, this is the family of a chord. And in particular solution, okay, particular solution is one solution. तो particular solution क्या होगा? Particular solution is a single chord. A single chord. Okay, this is a single chord. Okay. So general solution is nothing but this is a family of a chord. Family of a chord. Because why it is a family of a chord? Because the general solution contains arbitrary constants. तुम constant को value change करोगे तो क्या होगा? Different solution आएगा. Okay, so that is it is a family of a chord. तो constant का value जितना change करोगे उतना solution आएगा. ओके, बट पर्टिकुलर सॉल्यूशन में क्या होगा? पर्टिकुलर सॉल्यूशन में हम एक पर्टिकुलर वैल्यू के लिए सॉल्यूशन फाइंड करें. ओके, तो ओनली वन कर्व विल कम. ओनली वन कर्व विल कम. अंडरस्टूड माय पॉइंट्स?
Yes, sir.
Yes, sir.
Yes, sir.
ओके. तो ओके, so let us see. So you can solve the exercise 1.1 on your book. Okay. You can solve question number 1 to 14, 1 to 15. Okay. So in 1.1, okay, exercise 1.1, okay, 1.1, question number 1 to 15. Exercise 1.1, question number 1 to 15, you can solve. Okay.
Yes.
Yes, sir.
Okay, next class we discuss. Okay, so thank you all. You write your roll number in the chat box. Okay, I will share the note of this 1.1. Okay, I will share the note.
Thank you, sir.
Hmm.
Thank you, sir.
Thank you all.
Thank you, sir.
Thank you, sir.
Thank
Thank
you,
you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.